Hi everyone, it is Miss Sykes here. Today we're going to try something a little different called a flipped lesson. So how it is going to work is I'm going to teach and present the information I would normally share in class with you right now. And then in class tomorrow, we are going to do an activity based on the content in this video. So a couple of things. On the screen, you do not have to pull up anything. What you will need to see will be on the screen. This is what I am seeing as well, and you'll see me in the bottom left corner of your screen. The document I gave to you in class is what you will want to have out as we go through this video. This will be something you may want to reference for tomorrow's activity. Please watch the whole video, as all the content in here is important to know for the activity we will be doing in class. This video will need to be watched, and the note sheet will need to be completed in order to be able to participate tomorrow. Feel free to stop, pause, and rewind if you miss something or need to finish writing something down. That's what's really cool about these flipped lessons. So let's get started with the video to introduce us to the content we will be discussing today.
Now you can own these hit titles from Walt Disney Home Video. It was a quiet Saturday morning.
Zelensky! Give it a rest! It's Saturday!
Professor Wayne Zelensky was hard at work on his new invention.
This thing works. We'll put us right up there with the invention of electricity.
That didn't quite work.
Did you get the machine to work?
A few more bucks to get out.
Then something quite unexpected
Where are
happened.
the kids?
I haven't seen it since I left this morning.
It shrunk the kids.
Nick, what happened?
It works. Diane, I got something real important to tell you.
Are you trying to tell me the machine works? Do the kids know?
Well, yeah, the kids know.
That's great!
It's not that great.
Why?
I shrunk the kids, and the Thompson kids too. They're about this big. Threw them out with the trash.
What?
They're in the backyard.
Walt Disney Home Video presents The Last Frontier.
Dad can fix us, right, Nick? Sprinklers!
I'll tell you their size. It's a jungle out there.
Nicky, get out of there!
So, how does this film relate to our lesson today? Well, let's listen to find out. So, last class we discussed 3 types of transformations. The first one was a translation. This is where the only thing that changes in the object is the location. The second one was a reflection, and this is where there is a line of reflection and the object flips over that line. And the third one was called a rotation, and this is where the object turns. So transformations are congruent. They can slide, turn, and flip, but they stay the same size. Today we're going to discuss dilations. And dilations are similarity transformations that enlarge or reduce a figure proportionally with respect to a center point or a scale factor. If you need a little refresher with those vocab words, I put those on the screen as well. A center point is a fixed point where a transformation is performed, and a scale factor is a ratio in length of the corresponding sides of 2 similar polygons. So an example of a dilation is when a photographer takes a picture. They can see a negative print and create scaled reproductions of them, smaller or larger. Here's some other examples of dilations. We have measuring cups, dolls, a piece of art, and I pulled up Van Gogh's painting of Starry Night. As you can see, there's the original image, and then you can scale it down to a size that you're looking for. So yeah, we see these in everyday life, everyday situations. There are 2 types of dilations. The first one is an enlargement, and that's where a dilation has a scale factor that is greater than 1. So that means we start with a smaller image, and then it goes down, it shrinks in size. And then the second one is a reduction. So this is a dilation with a scale factor between 0 and 1. So this one, we have a larger image, and then we make it smaller. So the 2 types, enlargement and reduction. That's what we'll be working with today. So we're first going to start with an example of a scale factor to refresh our memory. So this, you will need to know if you are given an image or 2 images and they want to know what the scale factor is, the similarity of them for the dilation. So let's practice one of those. So the vertices for the blue triangle, which is triangle A right here, are -3, 2, or -3, 2, and then 3, 2. And then for the green triangle B, -1.5, 1, and 1.5, 1. So they want us to find the scale factor. How much larger is triangle A than triangle B? So I think on your note sheet it said we're going to start with triangle A and go to triangle B. So we're comparing triangle B to triangle A. This is from our ratios and proportions, so if you need a refresher on that, make sure to look at your notes. We know from that, though, that we can write it in 3 different ways, one of them being a fraction. So we can write it like B over A. And we could use any 2 corresponding vertices, but let's just use the first x coordinates of each of them. So triangle B is a smaller one, so that means it's this one. So it's negative 1.5 over negative 3. This can be reduced. We can divide each of them by 1.5, negative 1.5 for that matter. So we get the scale factor to be 1/2. So that means we shrunk triangle A, all of its vertices by 1/2 to get triangle B. It was a reduction. We shrunk it to this image B. Okay, so now let's go into dilations itself. So this is the first example on your note sheet. Let's first just graph the original coordinates to see what we are working with. So point A is 2, 2. Point B is negative 2, 2. C, negative 2, negative 2. And D, 2, negative 2. So we're working with a square. It tells us our scale factor is 3, so that's greater than 1. So that means we are going to produce an enlargement with this dilation. So we know our scale factor is 3. How are we supposed to find the new coordinates? Well, all you have to do is multiply your scale factor, so ours is 3, by all of the coordinates and from the original given. We're lucky enough that all of these are 2s, so every answer is going to be either 6 or negative 6. So we're just multiplying each of these vertices by 3 to get our new coordinates. So coordinate A becomes 6, 6. Sorry, getting used to this. Coordinate B will be negative 6, 6. Coordinate C will be negative 6, 6. Wow, those are rough. I'm very sorry. Coordinate D will be 6, negative 6. So let's graph those to make sure that's reasonable. So we have 6, 6. We have negative 6, 6. Negative 6, negative 6. And 6, negative 6. Let's draw our lines. So our goal is to make an enlargement. We knew our scale factor was 3, so greater than 1 enlargement. It sure looks like we went from smaller to bigger, so I think we did it the correct way, and I think this looks good. So let's move on to example 2. Let's graph our coordinates again, our original coordinates first. We have A is 0, 0. B is 0, 12. It doesn't fit on the graph, so just make it a little above it. C is over 12, up 0, so that's over here. Let's connect our lines so we can see what we're working with. And we have a triangle. Our scale factor is 1/4, so that is between 0 and 1, which means we will need to make a reduction. So how are we supposed to get our original coordinates smaller and reduce it by 1/4? Well, again, all you have to do is multiply your original coordinates by your scale factor. It works the same for both ways. So A, 0 times 1/4, we all know that that's 0. So it's going to be the same point again. So we'll just make it a little darker so we can see that. For B, it's 0 again, but then 12. So we have 12 and we have to multiply it by a fourth. And from our rules of multiplying fractions, we can pretend this has a 1. Multiply numerator, numerator, denominator, denominator. So we get 12 over 4. Well, what's 12 divided by 4? That reduces to 3. So we know that our new b coordinate is going to be 0, 3. So over 0, up 3. C, well, it's the same number, so we're still going to get 3 again, but then this coordinate will be 3, 0. So we're going to go over 3, up 0. So that's right here. Let's connect our lines again. And we needed to make it smaller, and I think we definitely did that. And the reason we knew we had to make it smaller is because our scale factor is between 0 and 1. So I think, once again, it looks very reasonable, and we did our job with this dilation. So today, let's recap. In our flipped lesson, we explored dilations. We found out how scale factors are incorporated in dilations. We then drew them on coordinate planes and used the scale factors to reduce or enlarge them. We know that dilations are similar because they are the same shape but are different size and proportional to each other. It's important that we know that, size and proportional to each other. Different size and proportional. On the back side of this note sheet are a couple of dilation problems I would like for you to try before tomorrow's class. There is also a question I would like for you to answer. And then also make sure to write down any questions you want to ask me or a classmate tomorrow about the content of this video. But remember, this worksheet must be completed in order to participate tomorrow. And you won't want to miss it because here is a sneak peek of what we will be working with in tomorrow's class.
Taste a world of freshness with Mentos Pure Fresh Gum.
Watch Gino get ready to hit it all the way down the court with Michael going, maybe? Yep, there it is. Michael Jordan on the breakaway. Wow. 37 for Jordan. It's a 20-point that just sort of went snuggling in. Like he was looking for the rebound all alone, and you had about 80 feet of court wide open. And
Alrighty, guys. Thanks for watching, and I will see you tomorrow in class. Have a good night.